Welcome students. In this lecture, let us look at the different evaluation methodologies for a machine learning algorithm. So when you develop a machine learning algorithm, you need to make sure that that machine learning algorithm is giving you the best possible efficiency for any application. Most of the time, it will not give you the best possible results. So in that case, you need fine tuning and different other parameters you need to check whether it is working in the best way or not. So the steps which a researcher need to follow once a machine learning algorithm is developed is you need to divide your data set into two halves. One is the training data set and the testing data set. And you need to evaluate all the machine learning algorithms which you developed with the help of the testing data set. And these we call it as performance metrics or performance measures. So the results will give you a clear idea on how your machine learning algorithm is working on. Sometimes the problem may be with the data set which you have. Sometimes the problem may be the mismatch between the application and the selection of machine learning algorithms, or there may be some other problem like hyperparameter failure also. Whatever it may be, you need to understand what is the level of efficiency which you are getting for your application. If not, you need to fine tune it. So in that case, you need to make sure that you evaluate the machine learning algorithms. So there are different ways for evaluating the machine learning algorithms. For example, you have different performance metrics for classification applications. You have different performance measures for regression. You have different performance measures for clustering and different performance measures for association applications. These mathematical or performance metrics are going to give you a score or a value with which you can come to a conclusion whether your methodology is working well or not. So as I already told you, this evaluation should be done only on the testing data set. So the next question you will get in your mind is how should I divide the training and the testing data set? The ideal percentage is 66 is to 34 or 70 is to 30, 60 is to 40, with the majority being the training and the minority being the testing percentage. These are some good levels which shows that you are giving sufficient amount of data for the machine to learn, and at the same time you are not going to give very less data for the testing process. So once done, now you select 70 percentage, so for example, of the training data set. Now the question is which 70 should I select? Say for example, you have 100 images for training process. Among that 100, 70 you need to pick. Which 70 are you going to pick? Sometimes an image may have more information which may be suitable for the training, but visually you will not be able to find that. In that case, we are going to avoid the partiality and give equal emphasis for all the images in the complete data set. How are we going to do that? For that, we have a procedure called as cross validation. So in this cross validation, if you have 100 or 90 data or images, say for example, in your application, you can divide it into many groups. I am going to divide my data into three groups, 30, 30, 30, right? And each group is called as fold. And now I know that approximately it is 70 is to 30 percentage. So initially I will take first two groups, that is 60 for my training and leave the other 30 for the testing. Again, what I will do is I am going to repeat the same experiment with a different training. Now I will take the next two training data set and leave the first as for the testing. Likewise, I will go for another round of experiment with the remaining two training data set. So here I have given an example. For example, you can divide into any number of groups. Here I have divided into three, so it is a threefold cross validation. First, I'm going to train on folds 1 and 2, and the testing will be done on 3, and the other two procedures are also carried out. The only problem you will face here is the repeated number of experiments which you do, but you can be very confident that you are going to get a good accuracy for your application. Specifically the data set which you have may be of various performance measures. So in that case, the bias will be removed and you can have a very good accuracy. Now, once you have the training data set, testing data set done, now you have carried out your experiments. Now, after carrying out your experiments, we are going to get some results in the form of a SNO, which we call it as confusion matrix. I will talk about the confusion matrix and the performance measures in my next presentation. Thank you.